Welcome to the CBT Nugget series for designing and implementing your server infrastructure. I'm Chris Ward. This nugget all about advanced DHCP. Now, for some of you, this might not be super advanced, but it is more than your basic understanding of just authorizing a DHCP server and then maybe putting a scope on it and then letting it run. In fact, we're going to be talking about some really cool things that are very exam testable. When I said it was going to kick it up a notch, what I'm really talking about is, of course, some of the more advanced features that you're going to see with DHCP. Number one, we're going to take a look at some design considerations for DHCP version 6, some things to think about, whether you're going to use stateless or stateful, how that's going to set up, why it's important to do one rather than the other. We're going to talk about filtering DHCP, or what some people would like to call either MAC filtering or link layer filtering. And then finally, we're going to touch a little bit on database maintenance. How do we back up our DHCP database, and what if we need to restore it? How do we do that? Before we dive into the advanced things, a couple of the basic things that you do need to know, possibly in that 70-413 exam, that we don't really cover in this series of nuggets. And the reason why is they're very basic things, like creating scopes and reservations in DHCP, creating super scopes, multicast scopes, authorizing DHCP servers, and even just the basics of DHCP version 6. But I'm not going to leave you hanging there. There's obviously a great way for you to get this knowledge if you don't have it, and that is to check out James Conrad's 70-410 R2 and Greg Shields' 70-412 R2 series, and just find the DHCP nuggets, click on them, and you will be set and ready to go. Nothing major here. Any of this is real simple. In fact, you'll even see kind of when we look at our DHCP console where you can do these particular basic items. Anytime you talk about IP version 6, most people I know kind of put their head slightly in their hands. They kind of massage their temples just a little bit because they're like, oh my goodness, it's so big and it's so hard for a lot of people. And trust me, I mean, we've been around for what now, 14, 15 years that people have said IP version 6, it's going to be out next year or in the next couple of years, and they keep kicking that can down the road. Well, it's around and people are using it, and DHCP version 6 is up there in Windows Server 2012 R2. Now, what happens is you want to manage IP version 6 with DHCP, but there are several ways that you can assign IP version 6 addresses and any other configuration settings, and the way that you can do this is either of one or two ways. You can do stateless configuration, which literally involves no DHCP version 6 server, or you can use stateful, which obviously involves a DHCP version 6 server. So to kind of help me remember it, I always remember that the state is full of servers. And that's how I remember stateful over stateless. Now, stateless address configuration, basically, it's based on the receipt of router advertisement messages. And so your routers need to be supporting IP version 6, and it takes care of that. And they got some great stuff, by the way. Jeremy Chara and Keith Barker talk about it in some of their Nugget series. Check that out. If you're really big into IP version 6 and you want more information on how that all works, that is a great series. Either one of them is a great series for you to use. Now, stateful is based on the use of what we would call a stateful address configuration protocol. In this case, guess what it is? They just call it DHCP version 6. It's still dynamic host configuration protocol. It's just now able to handle IP version 6. Now, a host is going to use stateful address configuration when it receives instructions to do so as part of the router advertisement messages, but it will use the stateful address configuration protocol when there are no routers present on the local link. Okay, so that's how you would use stateful. Now, you can do a combination, which is going to be based on the receipt of the router advertisement messages, and of course you can use DHCP version 6 as well. If you are going to use the auto configuration, including the stateful or stateless, you go through these states basically, and remember the whole DORA, the discover, offer, reply, and accept, the whole thing that you do with DHCP, and that's how you get your IP address. Well, during the configuration of your client, you are going to go through a couple of different states, and it might be important for you to kind of remember this. Tentative means that you are basically, you have an address, so you have one, so we'll give a check, but it's still being checked out. Basically, they're using duplicate address detection, and it's going to say, is anybody else out there with a address like this? Because it has to be unique. Remember, every address needs to be unique. And the node will not receive unicast traffic as long as you're in tentative mode. Now, once it is validated, ding, check, now you have a unique address. The computer says, all right, I can get unicast traffic on that address. Preferred means that you can enable a node to send and receive unicast traffic, where you literally say, yes, I already know that this is a appropriate address. Go ahead and start sending traffic to it. Then you can move it into deprecated, which basically the address is still valid, but you don't want any new communication to go to that. And then finally, there's invalid. Invalid, basically, the address is no longer allowed on the node to send or receive unicast traffic. It is invalid, which obviously is different than valid. So this one's like, nope, you're not going to be able to send. So those are just some design configurations or considerations for configuring DHCP version 6. Now, why would we want to use stateful? Well, you want to control how IP version 6 addresses are assigned. And because DHCP version 6 allows you to configure all kinds of scope options, like the address of the DNS servers and maybe some other priorities and some options that you have, well, guess what? You do need to use the DHCP server. And so when it does, by the way, IP version 6 talks with the DHCP server, guess what it uses? And this is kind of cool. Remember this. It uses multicast. Dun, 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 dun. That's great. Why? Because IP version 4 uses, remember, broadcast. That's why you need those bootp relay agents to be able to move across your routers. And that's why a lot of people are saying, boy, it's really cool because multicast, obviously, it helps us cut down on any of that broadcast traffic that we have in our environment. When we talk about DHCP filtering, we're basically saying we are going to use the client's MAC address to either allow or deny the IP address configuration. This is sometimes called link layer filtering, so you can kind of see it either way in some of the documentation. So basically, every NIC, even if it's a virtual NIC, has a MAC address, right? That's that layer 2. That's why they call it link layer filtering, layer 2 address. It's a hardware-based address. And so over here in your database, you'll have MAC addresses, okay, that you can put into your database. And what it'll say is, all right, this guy will come in and start doing the DORA, the discover, offer, reply, and accept, okay? So it'll do that, and the first thing that the DHCP server is going to say, let me go see if your MAC address is in my list. Oh, it is. Now, is it allowed or is it on a deny list? If it's on an allow, it's great, no problem, and it hands out the IP address. If it is on the deny, obviously it says, nope, sorry, no IP address for you. But let me go show you where this is set up so that way you know how to do it. Now, to do filtering, obviously it makes it pretty simple right here. Under your scope or IP version 4 here, you can have your filters. You can allow and you can deny, either one. And right now we don't have any right now, so we can go ahead and right click on the allow here and it'll say new filter. So we click on that. We can give the MAC address, which is going to be a 6 hexadecimal number representing the MAC address, and then we can give it a description. We could say the CEO's laptop, and then we just simply click add right here. Now I don't have a MAC address in place, but otherwise I put it in here. Once you do that, you can then of course have it where it is allowed. It's that simple. It's also that simple to deny it based on it. Just simply go new filter, put in there, and then add a description. Lowly IT guy like Jake Rolfe, and then put it in there. Now Jake is not a lowly IT guy. He is the kingpin, him and Kurt, out there at CBT Nuggets. But you can put the MAC address of somebody that's in here, and that way it would be denied. And maybe this is because you've got a machine that's been giving you problems. You can actually deny it so it doesn't go out on the network and start causing problems just by using a little bit of sniffing on your connection. You can actually find this information, put it in here, and that way you can stop maybe a lot of extraneous traffic. Just something that you can think of. So it's that simple just to do that when you want to be doing filtering. Now the thing about the DHCP database is it's literally a database of information, and important, it is a dynamic database of your clients, and of course any client information is placed onto this database. Now the size of the database obviously depends on how many DHCP clients that you have on that particular database or DHCP server. So if you've got 4 or 5 different scopes where you've got maybe 200 clients on one scope, maybe you're doing a Class C type of environment, and you've got a 172.16.0.0/24, and then you do the 1.0, the 2.0, and that kind of thing, then obviously the more you add, each one of those scopes could have, of course, up to 252 addresses there. So that starts adding up, and so especially if you've got everybody taking those IP addresses. But think about it, over time some of these entries become obsolete and they are of course deleted, and what they do is you can recover unused space, and this happens automatically or automagically, as Brian Alderman likes to say. The DHCP database is going to be compacted, so that part is pretty much behind the scenes, and obviously you need to plan appropriately for your DHCP servers. But check this out. We've got abilities to, and this is important, we want to back up and or restore our DHCP database. And the other thing you can do is, even with a backup, if you do that, you can then migrate it over to another server. So once you do a backup, you can migrate that database over, bring that back up as a restoration on that other server, and then you've migrated that information to that DHCP server. So that's something that you might want to do. So let's show you where you can do that and how you would do that. Now, if you're worried because you said, Chris, I've never backed up my DHCP server, what am I going to do? Well, don't worry. There's synchronous backups that occur automatically, and the backup interval is about 60 minutes. And you can change that, by the way, by going into your registry and doing that. But what you can do also is your DHCP database is also part of your Windows backup or any other backup software, because it's obviously right there on your machine. And when you do this backup, you're going to get the whole entire kit and caboodle, as we like to say here in the States. All the scopes, super scopes, multicast scopes, the reservations, the leases, all the options, things like your server options, your reservation options, etc., and then all registry keys and configuration settings that you might have done. Some people like to do audit log settings or folder location settings in the DHCP server properties, and so that is all part of the parameters, and that is backed up. Now, to do this manually, of course, you merely come up to the DHCP server, which is right here. You right-click, and you notice you have your 2 commands. You have your backup, and you have your restore. So you click on backup, and it's going to say, where do you want the backed up files? Now notice, by default, it's in the System32 DHCP backup. And if you scroll down here, you've got the new. Now you can keep this, or you can create maybe a new folder. So if you click on Make New Folder, and we could maybe call this Migration, just in case we want to migrate, right? So you go ahead and do that, you click on OK, and bada bing, bada boom, it goes off to the races and backs up all that information that is now available in that particular folder. Now, why did I do that in the migration folder? Well, here's the dealio. If I leave it in the standard place, guess what happens when the synchronous backup comes in 60 minutes or whenever it's going to happen? Well, the manual backup is then overwritten. So if that was the one you wanted to use for the migration, because it has a, you have it set up and you just want to test something, so you back it up and you put it over in another, you put it in the same folder, and then meanwhile you're all happy and you're doing all these changes because you think, don't worry, I get a backup. So if I blow things up, I can just restore from that backup. Au contraire, mon frere. What will happen is if you go past that synchronous 60-minute time, which could be 20 minutes from when you backed up, 15 minutes from when you backed up, or whatever it is, then it will overwrite it. And then you will be stuck with whatever changes you have. And if they've blown up your server, I mean, it shouldn't, but it might happen, then you're stuck. You're going to have to blow everything out and start over, which I don't know about you, on a large system where you've got scopes up and down here and everything, that would be a bad thing. But in this case, we can right-click on it, you can click on Restore, and it says, all right, where can you find up the backed up files? Now notice, you've got backup and you've got migration. And under migration, look at this. You've got the new. So when I do migration, that's where it's going to go find these backups, which are located in this folder. Whereas if you do the regular backup, it's going to find them in here. So in this case, I can go to migration. I go ahead and click on OK. It's going to say it's going to stop and restart. Would you like to do this now? I'm not going to do that. That's fine. But we just click on no. And that's where it's going to go in, and it will restore back all of the database information that's included in that database backup file. Now in this case, I have everything pretty much in the same environment and on the same drive. One of the advanced features you want to think about is you don't want to store your server backups on the same hard drive on which the DHCP service is actually installed, because that way, if that blows up, if it's a bad drive, you've lost it anyway. Oh yeah, it's great. I've got a backup on the same drive that just went down. So it's important. A lot of times they recommend that you go ahead and you do that. Plus, make sure that only the administrators group and the DHCP administrators group are members. That's just a security level thing that you want to do. So let me show you real quick where all this is and why it's important to do that. So we'll click on our Explorer here. We'll go to local disk, go to Windows, scroll down here to System 32, find our DHCP, and here we go. So under the backup, you'll notice something. You have your database file. Here it is right here. You've got your DHCP PAT file, and then you've got log information, and then of course your JRS files that you have in place. Okay, so this is all here, and you'll notice that some of this stuff has been, you got a recovered file fragment and things that have been going on here because maybe some changes. Now that's good for there, right? But let me go to backup. And you'll notice that here under the backup, you've got the new, which is where its standard is, and the DHCP config file, which is set up. Now watch when I go to the new. This is still under the backup, right? And new. Here is all the information that's been backed up. And of course, it's in text document format, as well as the MDB file and the PAT file. Notice the time that it was backed up, 1045, right? So let's go back to backup and go to migration. And you're going to notice something. Look at the timestamp, 1106. So basically, I've come in, and if I would have done this and just done it in the regular way, it would have overwritten all that information in the new and the DHCP config file. But in this case now, I've got a new one here, again, 1106, 1106, and you can see that this is all set up and ready to go. So this is great because that means that I have obviously now got a manual backup, and what do I need to do? I just take this information, new DHCP config, I take this and export it and then restore it on another DHCP server if I want to do a migration. So there you go. That's our maintaining our DHCP database. We also look at filtering and DHCP version 6. I hope this has been informative for you, and I'd like to thank you for joining me.